Welcome students. Today we are going to perform our experiment 2. In the last experiment, we have learned about different electrical equipments that we are going to use in our lab, such as resistors, capacitors, breadboard, multimeter, etc. Now today we are going to learn how to build circuits in breadboard and how to measure the voltage and currents across each element. Also, we will learn about measurement uncertainty. To perform today's lab, the equipment we are going to use is the DC voltage supply. So from this one, we can supply any kind of DC voltage, a breadboard, a bag of resistances, and a multimeter. To start with, for the very first part, it tells to pick up any two resistances from your bag and find out the value R, that is the color code value of a resistance, and measure the same resistance with the multimeter and note them down as Rm and find out the error from this equation. So to do so, let's take a resistance from the bag. So the resistance I am having, this one, maybe the color is not visible properly. Yeah, so this one is having the brown, green, red and golden, if you can see it. So for this one, the value should be 1500 ohm. So measure the same resistance using the multimeter. So to do so, this is our breadboard. Actually, we never measured the resistances holding on hand because it will include our body resistances with it. So that's why either put it in the table and hold two leads here like this, or you can put the resistance in the breadboard and then put the multimeter along to this leg, and then you can find the value of the resistance. So as you can remember, this is the breadboard. So all the horizontal lines are open and the vertical lines are shorted. So to place a resistors in the breadboard, what we need to do, we need to put it like this way, so that there is a gap between the two legs of the resistances. As you can see, I have put it in here and there. So there is two gaps between the resistance legs, so that this is the resistance that will act into the circuit. So now let's do it. This is our multimeter. So for that one, we need to put it in the ohmic range. So obviously we always should start from the very lower range. So this is the range for the resistances. So that means if the regulator is in this portion, it can maximum measure 200 ohm. Similarly, if it is here at 2K, so it can at max measure 2K ohm. So if it is the value of a resistance is 3 kilo ohm, then we need to increase the range of this multimeter. So this is the way we measure the resistance. So obviously we should start always from the smaller ranges, and these are the two leads. So one is red and one is black. So black will always go to the common ground, which is marked as black as well. And for measuring the resistance, as you can see, this red hole, it has the capacity of measuring hertz, that is the frequency, voltage and ohm. So we will put it here. So our multimeter is ready. Now if we place the two legs of the resistance here, two legs of the multimeter across the resistance, then we can measure the value of our resistance through the multimeter. So here the value is showing OL, that means it's open. So we need to increase the range a little bit. So if I do so, I can find the value of the resistance is 1.487. So the unit here is kilo, so we should call it 1.487 kilo ohm. So we have our R value and Rm value. Now here this is our R value and this is our Rm value. So Rm value is 1.487 kilo ohm. For that one, if we put these two values into the error equation, we find out the error for 0.87%. And if you can remember, the fourth band of the resistance was golden. That means the tolerance is plus minus 5%. So we can say that our error rate is less than the tolerance limit. That means our resistance is okay to use. So this is the first part for the procedure, and you need to repeat that for another resistance from your bag. Now in the second part of the procedure, we need to build this circuit into the breadboard, and this is the symbol for voltmeter, this is the symbol for ammeter. So we need to measure the voltage and current across this resistance, and we will also see how we can supply a DC voltage. To do so, this is our equipment from where we can supply DC. So first turn it on, and as you can see, there are multiple knobs here. So for the very first part, it has 6 volt. So this is the positive and the negative. So it can at max supply 6 volt if you connect from these 2 points. And also there are 3 ports here. So it can provide you plus minus 25 volt. So if you connect the positive here, suppose let's take 2 alligator probes. These are called the alligator probes. So let's connect it here, and another should be in common. So if we connect between these 2 points, so we will get positive, maximum positive 25 volt. So from here, first we need to select the range. So if we are at these 2 knobs, then we will select plus 6. If we are here, then we will select plus 25. If we are here negative and common, then we will say negative 25. So as this at this moment, for all the labs we are doing, we will use the positive and the common at the plus minus 25 section. So select the positive 25 volt from there. So if you select that, you can see this value at that point. So now you need to set the display limit. So if you do so, we will set the current limit for the display. So here is the, as you can see, if you go to the display limit, it's blinking at that point. So now move to the current limit. This is the knob from where we can switch to voltage to current. Now it is blinking on here. Set the value to 0.02 amps. So our limit is set it up to 0.02 amp. Then close it. Then go to the output. When you start the output on and off, if it is on, then you can supply the voltage from there. Again, the cursor is at current. So now move it back to voltage mode. So now if you move this regulator, it will give you the voltage. Suppose we are setting up 5 here, so that means across these 2 points we are going to get 5 volts. So obviously the red one, as we connected it to the positive, it will give us a positive supply, and the black one we connected to the negative or common, it will give the negative one. So let's put the voltmeter here. So again, I hope you guys can see it. Yeah, so it is off now. Whenever you are using the multimeter, after you are done with using, turn that off, otherwise the battery will drain out. So we are supplying 5 volt from there. Now we need to choose the range. Again, there are ranges from, this is the section where we will put the voltage, and the ranges are starting from 20 milliamps to 1000 volts. So we are supplying 5 volt. To check that voltage, we have to have at least 20 volt range. So now connect the positive with the red one and the negative with the black one. So this is the positive port of the DC multimeter, and this is the negative port of the multimeter. So we will connect accordingly. So now as you can see, it will measure the voltage value at 5.01. So here as you can see, we are supplying 5 voltage, but we are getting a little bit change on it. So that is called the measurement uncertainty. So when you are measuring anything, at that moment you might not expect to get exact value that you are supposed to get. So that's why when we are measuring anything, it's a good practice to measure several times and get a average value. Now let's build this circuit. So here, as you can see, there is a resistance of 1500 ohm. With that we need to supply a voltage. So this arrow actually symbolizes that you need to change or you need to vary the value of the voltage. So for that part you need to supply from 0 to 5 volt with a step of 1, and then you need to measure the voltage and currents across this element. So for doing so, this is our resistance that we have connected already in the breadboard. So as you can see, we are putting these two legs horizontal position so that there will be a open space in between. If we put, suppose, in this way, that will also work, because as you can remember, this is the junction from FE to F, there is no connection. So you can put your resistances like this as well, but you cannot put them in the same line. So if you put them in the same line, suppose here and here, then it will get shorted and it will not act. So let's put back to the correct position. So this is the way I am putting the resistance. And now let's take two jumper cable, because at this leg I want to supply the positive and this leg I will supply the negative. So I am putting the jumper cables here. So as you can see, at the first hole I have put the resistance leg, and immediately below I have put the jumper cables. So don't put at the same pore, because it might damage the breadboard. So connect in this way. Now I will connect the positive of the supply to the positive here. So for safety, before connecting, turn off the output. So if you turn it off, then there will be no connection. So check it with your TA when you are done with this connection. So this is your positive is coming to the circuit, going through the resistance and getting back to the negative or common port of the supply. So our circuit is completed. Now let's measure the voltage across an element. So as you can see, this is our circuit, the positive and negative is here. So if we want to measure the voltage, this is the positive terminal of the multimeter and this is the negative terminal of the multimeter. So just put them across the resistance. So if you do so, you can see we are supplying 5 volt and we are getting the 5 volt exactly. So this is the way we measure the voltage. Now let's measure the current through the element. To do so, the first thing we need to change, this is for voltage measurement and these are for the current measurement. So if you put the red knob, the red port here in the milliamperic range, it will measure the milliamperic values of current, and if you have higher currents then you should put it here. But in all the experiments in the lab, we are using the circuit which will have a milliamperic range current. So always put the red one here. So as you can see, it's making some noise. That means you put the red knob in a position but your regulator in the wrong range. So if you come to the ammeter zone, then it will stop and you are measuring everything in milliamperic range. So let's start from the smaller range. So this is the setup for the multimeter. Now set the circuit. So to measure the current through the circuit, we need to put the ammeter in series. To do so, move one leg of the resistance to a different place, make a space between the previous one and the new space and fill up the gap with your multimeter. So now you can measure. So this is 3.4. So your current is 3.4 milliampere. So I'm repeating again, you need to move the position of the resistance leg so that you can put the ammeter in series, and then fill up the gap with your multimeter. So the positive will go to the positive side and the negative will go to the negative side. So if you just change the polarity, suppose if I put the negative to the positive side and it's here, you can see it will show you a negative value. That means the way you are placing your multimeter should be in the reversal position. This is the way we measure the current. When you are done measuring the current values, so put the resistance leg back to its original position so that the circuit will be completed again. And for this part of the procedure, what you need to do, you need to measure the voltage and current across this element for different voltages. So supply from 0 to 5 volt with a step of 1. So for supply 1 volt and measure the voltage and current. Again increase, supply 2 volt, measure the voltage and current here. So in this way, from 0 to 5 with a step of 1, you need to measure the voltage and current and then plot them V versus I curve in a Excel. Let's move on to the third part of the procedure. So in this part, you need to build this circuit. The supply voltage should be 2 volt and the first resistance should be 1000 ohm. And you need to find out the value of R. So in the problem it says the voltage is equally divided between these two resistances. So if it is equal, so it should have 1 volt and the other resistance also should have 1 volt. So then the resistance values should be equal. So we will have the 1000 ohm for this value. So let's build this circuit and check our assumption is correct or not. So again I'm disconnecting everything from here. So this is my 1 kilo ohm resistance. I'm putting it here, and there should be another resistance that we predicted, that should be 1 kilo ohm again. So how can we put them in series? So wherever the leg is getting end up at the same point, not at the same point, in the same line, we will put the leg of the another resistance like this way, and then put it anywhere. The other leg should put in another place. So as you can see, this is our connection. This is the way we place them in series connection. And now put the voltage supply, so it will complete. So the positive of the supply is coming here, going through one resistance, and then it's going to the other resistance and getting back to the source. So now if we measure the voltages, so we are placing this one back to the voltage mode, and then let's measure the voltage across the first resistance. Yes, we are getting 1 volt, and again measure the voltage across the second resistance, and we are getting 1 volt again. That means the two resistance should be 1000 ohms to divide the voltage supply equally. So here our voltage was supplied to 2 volt. For the demonstration part, at first you need to take 4 1 kilo ohm resistances from the bag and then write down the color codes, then what should be your expected value, tolerance, and the measured value. So note down all the data in the Excel sheet in this way and find out the error as well. For the second part, it asks you to draw or plot the resistance values with the standard error. So in Excel, using these average values, the measured values, you will plot this graph and you will also find out the average value for the resistances. Show the standard error. If you are not know how to show this, so click on the plus here and go to the error bars and show the standard error, so that you can see how much error it's having. And for the number 3, build this circuit. So build this circuit in this way. So as you can see, this is our R1, it is connected here, R2 in series, and then this is your R3, and here it is the R4. So in that way you will make this circuit into the breadboard. And for the part 4, before supplying the power to your circuit, please show the circuit to your TA or the instructor. For part 5, 6 and 7, you need to do the same thing. So what you need to do, in this circuit you will supply 5 voltage and then measure the voltage across each of the elements. So for all 4 resistances you will measure the voltage and note them down. Once you are done, turn off the power supply and then again turn it on and supply 5 volt again and measure the same thing. So in that way you will measure 3 times across each of the element. Please turn off the supply and turn it on again. In this way we will check the measurement uncertainty. So for 5 volt you will complete this table, and for 10 volt supply again complete the table, and for 15 volt supply complete the table. In this way you will take all the measurements. When you are done taking all the measurements, then for step 8 you need to plot a curve. So here I just took all the average values of each of the resistances, the voltage of each of the resistances, and then I plot this one. So again you need to make a bar plot for each of the, in the x-axis there will be the number of the resistances, and in the y-axis there will be the amount of voltage drop. So for 5 volt supply, 10 volt and 15 volt supply we will have 3 graphs, and show the standard error for each of the curves. For number 9, you need to plot another graph, and there in the x-axis you should have the supply voltage, that means 5 volt, 10 volt and 15 volt. I just rearranged this table from the above table. So for 5 volt supply you will have the voltages across each of the element, 10 volt each of the element voltage, and for 15 volt the same thing, and then plot them. In the x-axis the supply voltage and in the y-axis the voltage across the resistances. When you are plotting, after that you need to check whether every single line is crossing the origin or not. Depending upon this plot, you need to answer the question 9 and 10 from the lab manual. In case you are not familiar how to make this graph, like plotting multiple scatter plot in a single figure, let me just show you. So go to insert and then go to the charts. Here you can choose a scatter plot using a line and then put all the values. So right click on the plot and then select data. So here you can add multiple data. So I'm putting for the series name, for the very first one I'm putting the VR1 as the series name. In the X value I will have the supply voltages, so 5, 10 and 15, all these 3, and then in the y-axis I will have the values, the voltages across R1 resistance. So these are the values. So in this way I will get my first plot. Then again add another one. So my series name should be the VR2, and the X values again the 5, 10 and 15, and the values across R2 resistance. Similar way I will add the other two. So VR3 will be my series name, X-axis 5, 10, 15, and the voltages across R3 resistances. And the last one, VR4, 5, 10, 15, and the voltages across R4 resistance. So in this way I will have all my data here. So press OK. So as you can see here, the voltages across VR2 and VR3 are almost equal. So that's why you are having a overlap here. So there are actually two resistances, two values, they are overlapping each other. So in this way, obviously do not forget to put the x-axis, y-axis and the chart title. So put that by your own. Go to the chart elements, then show the trend line. So again, for the VR1, the trend line it will show, and for more, right click on the format trend line and show the backward forecast. So yeah, so for the forecast, if you set the backward value to 5 and display the equation on chart, if you click these two, then you can see, you can show whether it is going through the origin or not. In similar fashion, you will do for the rest of the circuit, rest of the line. So show the trend line and then format the trend line, set the backward value to 5 and display equation on chart. So this is the way we should show it. And again, when you are done, then show the legends so that everything can be, the legends can be seen on the right side. So this is the way we actually make this plot. So complete these steps and plot a graph like this. If you are done with the demonstration, then in the lab, actually what you need to do, you will collect all the data for procedure and also for the demonstration. Just complete those tables and take all the data and do all the plottings at home. And after that, answer all the questions from the report and also show the results from your demonstration and procedure in the lab report. So that's all for experiment 2.